Hey guys, so every company today wants to build agentic applications and multi-agent systems for all the good reasons. And in this regard, there are two protocols that are trending in the AI industry. One is Model Context Protocol from Anthropic, and the other one is A2A Agent to Agent Protocol from Google. So I have already done a dedicated video on MCP, Model Context Protocol. You can go to my YouTube channel and see that. And but today's video is all about A2A agent to agent protocol. So let's understand what is A2A agent to agent protocol, how does it work, and what are the features of A2A. And at the end of this video, we will also see a simple tutorial of how A2A basically works. So let's get started. So the agent to agent protocol, A2A protocol, is Google's answer to the rapidly growing ecosystem surrounding AI agents. So in simplest terms, if I have to say, A2A enables communication between agents, allowing them to collaborate on tasks and work towards a common goal. Just like how the Model Context Protocol, MCP, Anthropic's Universal Remote, that standardizes how AI systems connect with tools and data sources. A2A basically aims to remove the complexity and challenges of multi-agent integration using a unified approach. That's about A2A. So even though A2A and MCP might seem like they are different, but they are actually designed to work together. Even though they address different aspects of AI integration, but they can complement with each other. As you can see in the diagram, right? MCP connects LLMs or agents to tools and data sources, kind of a vertical integration we can see. Whereas A2A connects agents to other agents. It's kind of a horizontal integration. So that's the main difference between MCP and A2A, but they can complement to each other. It's not whether I should use this or that. You can actually use both for proper workflows. So now we understood what is A2A protocol and how it is different from MCP. Let's understand how the A2A protocol basically works through a simple workflow. Right? So as you can see in the diagram image, it all starts with the agent discovery and then authentication, and then there is A2A protocol. That that is the sequence. So the A2A protocol begins when an entity, a human user or another AI agent, initiates a request to the client agent. For instance, a user might ask for assistance in scheduling a trip, or it can be anything, right? Once the client agent identifies a remote agent capable of fulfilling the designated task, it then goes through authentication according to the security schema indicated in the agent card. And then the communication starts with a client agent sending a task to the chosen remote agent. And this agent to agent communication occurs or happens over HTTPS for secure transport. So, in simple terms, when a user query comes in, it basically first understands, hey, is there an agent that can fulfill this particular task? That's where the agent discovery happens. And once we get that agent, we need to talk to that remote agent, right? The client agent talks to that remote agent through an authentication, and then the A2A protocol basically happens through over HTTPS for secure transport. And that is where the sequence basically completes. And this is how A2A protocol basically works. And let us see a simple tutorial to understand more about how actually A2A protocol works. Hey guys, so this is the agent to agent protocol workflow that we are building in our tutorial. There is a user query, and there are basically three agents, right, to talk to each other. And the it starts with the research agent, the summary agent, and we have the reviewer agent. And when a user query comes in, it basically goes to the vector database. We are using vector database, SingleStore as a vector database. It basically goes to the vector database and retrieves the facts grounded in vector DB, I mean, in our database. And then we have the summary agent, which basically summarizes the research in simple, clear points. And then there is a reviewer agent that refines and fact checks the summary for accuracy. And finally, we will get the proper response. So let's say this in action. Okay. So we already have the notebook code, everything is ready. And since we are using SingleStore as our vector database, so you can go to singlestore.com, sign up, and once you sign up, you will get some free credits. SingleStore has a free share tier. So once you sign up and sign in, this is where you will land. So this is where you land. Create a workspace for yourself and create a database. My workspace is already ready, and I have created a database attached to my workspace. My database name is A2A. Okay. So once you do that, one interesting thing about single store is it provides notebook feature where you can basically run all your code to visualize how the AI agents work and all the agentic workflows. So after that, after creating your workspace and creating a database, go to query editor. This is where you can basically create a new notebook. Create a new notebook, give it a name, just create. And then I have already created my notebook and I'm going to explain you step by step. So let it load. So I'm going to explain the same thing for you, right? So here is my complete code. So before starting off with your code, make sure you select your workspace and the database, right? Our workspace is PyWappy workspace and database is A2A. So here comes the A2A agent to agent protocol tutorial. So this is some simple explanation. What is A2A? It's a protocol that will allow AI agents to communicate with each other, securely exchange information and coordinate actions. We already saw how A2A basically works, the workflow we saw. And here is some more explanation about A2A basically empowers developers to build agents capable of connecting with any other agent built using the protocol and offers users the flexibility to combine agents from various providers. Right. So, like we discussed in the image or workflow diagram, we have three agents basically. That is research agent, summary agent, and reviewer agent. Research agent retrieves facts grounded in our vector database. Single store is our vector database. And summary agent basically summarizes the research in simple, clear points. And at the end, reviewer agent refines and fact checks the summary for accuracy. So each agent has, as you can see, each agent has a specific role, operates in isolation, does not share memory or tools, and receives and sends natural language messages. And we are basically, you can see there A2A message class, which is the main core concept of A2A protocol. So it has the sender, recipient, content, and timestamp on it. And there is A2A message passing workflow also. So here is how the flow basically works. We already saw that, but let's see it again. The user with his query, it goes to the research agent. The query is like, what about generating math problems with GPT-4? That is the user query. It goes to the research agent, and then the research agent basically retrieves the relevant text chunks from single store, uses them to construct a response, and then sends it to summary agent because summary agent is the next agent that comes in because that needs to summarize. And summary agent basically receives that response, summarizes it, sends it to the next agent that is reviewer agent. And then now the reviewer agent basically refines and fact checks the summary, sends final version back to user. So no shared memory, no tool access, just natural language message passed across isolated agents. So all these agents are isolated, but they come together to basically help us with this A2A protocol workflow. So we already saw the workflow, and now let's get started with the code part, right? We need to install the required packages. We are using LangChain, OpenAI, SingleStoreDB, and and then we are going to use we are going to import necessary libraries. That's what we are doing here. And we are setting the credentials here. We need to have our OpenAI API key and we need to connect with our single store, right? For that, you need to know this host, port, user, password, and database. So how to get those things? If you go to deployments, there is a connect button, go to SQL ID, and you can easily get your password from here, admin, port, and host. So set all of that, set all your credentials and download and load the PDF. So this is the PDF we are using. So this PDF is about, let me see what the PDF is all about. It's about sparks of artificial general intelligence, early experiments with GPT-4. So that's what the PDF is all about. It's a research paper. So let's download that and PDF downloaded successfully with correct content type. And next is, extract and split the document into chunks. That's what we are doing. And we extracted and split the document into 613 chunks, right? And then now all the chunks need to be embedded to store in our vector store, that is SingleStore. That's what we are doing. And our table name is A2A docs inside our A2A database. And as you can see, ingested all document chunks into SingleStore vector DB. So what we have done so far, we loaded the PDF, we split the PDF into semantic chunks, and we assigned a numerical value for all these chunks. That's called vector embeddings, and we stored them in our single store, vector store. Now let's use this vectorized data in our A2A pipeline, right? So now we need to define the A2A message class. That's what we are doing here. We are defining the A2A message class, which is the core component of A2A protocol. And now also defining the updated A2A agent class for the agents we are using. And then we create the agents, right? The research agent along with its name and along with the task prompt, what it does. You are a research agent. Use the provider context to give accurate and relevant findings. And again comes the next agent, that is summary agent. Name is SummaryAgent, and this is the task prompt, what it has to do. And at last we have the reviewer agent and its task prompt. You are a reviewer agent, refine and fact check the summary to improve clarity and correctness. So now run the agent to agent workflow. That's what we are doing. We are running the agent to agent workflow here by combining everything together with all our agents together, and we can see the final output. So let's execute the protocol. So our question was, the user prompt was like, what are the early signs that GPT-4 might exhibit AGI behavior, right? So as you can see, it goes first to the user agent, sorry, the research agent. Please research what are the early signs that GPT-4 might exhibit AGI behavior. And next it goes to the from research agent, it hands over to the summary agent, and then the summary agent comes and it's like the document suggests that GPT-4 is showing signs of artificial general intelligence, blah blah blah. And then summary agent hands over the task to the reviewer agent. AI is increasingly influential in clinical decision making, blah blah blah. And then at the end we have the reviewer agent, which is finally giving you the prompt proper contextual response, right, with all the summary. Here comes the final reviewed summary for our query. What are the early signs that GPT-4 might exhibit AGI behavior? AI is playing significant role in clinical decision making, blah, blah, blah. And research suggests that GPT-4 displays behavior akin to artificial general intelligence AGI, as it not only accesses and presents vast amounts of information, but also applies in practical context, blah, 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 blah. So that's the summary. And you can also ask another topic like, what about generating math problems with GPT-4? That's our topic or prompt. And again, all the agents come together and where the agent task handover is done. And finally, you will get a final reviewed summary for our question prompt. What about generating math problems with GPT-4? As you can see, AI is becoming progressively influential in clinical decision making, blah, blah, blah. GPT-4's mathematical abilities were assessed using benchmark math datasets, demonstrating its capacity to answer high school level math questions and engage in advanced math topics, blah, 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 blah. That's how the A2A protocol basically works. And now let's see how our data has been stored in our vector database, that is SingleStore. Let's go to A2A was our database that we created. And A2A docs is the table. As you can see, the name, the sample data. These are the different columns. We have four columns: ID, content, vector, embeddings, and then metadata associated. So ID content. So content is from our research paper that we used, and it all got converted into vector embeddings, as you can see, which is useful in semantic searching and getting the proper context. So yeah, I mean that's how you can basically build A2A. Do learn A2A protocol. So that's it. That was a simple way to understand how agent-to-agent protocol basically works. Thanks for watching. I'm gonna share the repo link in the video description so that you can go and try it out yourself. Thanks, guys.